Bismillah. Okay, so this paper is actually 0620, paper 42, October, November 2021. Okay, this is question number 2. Let's have a look here. Acid, remember last week we did on alkali. Now we're talking about acid. Acid are important laboratory chemicals. Okay, some acid completely dissociate in water to form ions. So the key word here, completely dissociate in water to form ion. So they asked you, state the term applied to acid, okay, that completely dissociate in water. Okay, this is so easy. Your acid completely dissociate in water is called a strong acid. Let's do a bit of a theory here, yeah? So what do we use? Okay, strong acid. What is the characteristic of a strong acid? We said completely dissociate in water. Or another term, we say dissociate completely. Another way of saying, yeah, completely in water. Another word that we can use, we can say ionize. This is correct as well. Ionize completely in water. That is strong acid. What about, we have only two types of acid, strong and weak. What about weak acid? Well, it is the opposite. Dissociate or ionize. Dissociate. Okay, or ionize partially. We use partial, yeah, partially in water. So that's the difference. So in terms of definition, or I mean in trying to define what is a strong acid, what is a weak acid, we can use how, okay, they dissociate in water. For strong, we call it dissociate completely in water. For weak acid, we said dissociate partially in water. Now, what do you mean by that? Okay, we can actually give example here, yeah? Example. Before we even answer the question, like I said, although we are doing past paper, but this is also a lesson. So anything that I feel that, you know, that I can explain in terms of the theory, I will do so. I will try my best. Okay? So that's why we are not rushing. For example, what is a strong acid? I'll give another acid here. Hydrochloric acid is a strong acid, HCl. Okay. Now, dissociate in water, we have to use the two arrow. Okay, I cannot type the reversible arrows. I'm just going to type it like this, yeah? Should be reversible, the two arrow. So what will happen? Dissociate meaning it separate, yeah, into ions. So your HCl will separate completely. What do you mean by completely? Well, completely meaning into the simplest, yeah. So that is H plus. Don't misunderstood by this. H plus and Cl minus. There you go. So do you see what happened here? Your hydrochloric acid is made up of hydrogen ion and chloride ion. So when you separate it, it completely separate. So this is one of the way of saying dissociate completely. Okay, this is one of the example. Right. What about your weak acid? Okay, example here we can weak acid. Ethanoic acid is a weak acid. So CH3COOH. Okay. want to show it dissociate partially in water. One of the way of explaining this by saying that if you have ethanoic acid, you want to separate, yeah? You want to separate. So what will happen? What is the ion that you will get? You will get ethanoid ion, CH3COO minus. So that's the ethanoid ion. And then plus hydrogen ion, H plus. There you go. Now one might say, what is the difference? Okay, look. The difference is that for ethanoid ion, what do you get? You have a component of carbon, hydrogen, and oxygen. Yeah, this. Can I separate my component of carbon, hydrogen, and oxygen? I wanted to make like a, you know, the simplest ion. No, you cannot. This is the simplest that you can get. So this is one of the meaning, dissociate partially. Okay, whereas your HCl dissociate partially, you can see here, sorry, completely. It separate into the simplest component. Okay, so that is one meaning. I'm not saying this is the only meaning of dissociate completely and dissociate partially. Okay, let's try to answer the question now. So this is strong. And then complete the equation to show the complete dissociation of sulfuric acid. Okay, khalas. This is what we're going to do. So it's going to be hydrogen ion and sulfate H2, sulfate SO4 2 minus. Now remember the charge is supposed to be superscript, but you know, because I'm typing it here. So do not misunderstood here. So it should be superscript here. So let's do this. I'm just going to draw the charge here. So this is H plus here. SO. Remember in the exam you have to write down the symbol correctly. SO4 here. 2 minus. Right. Now let's try to balance this. It's not balanced. Why? Because we have 2 hydrogen. We got only 1 hydrogen. What do I need to put? Put in front. There's a number 2. Number 2. Okay. Right, there's a number 2 for hydrogen. What about sulfate? You can, when you want to balance, a shortcut way, is it correct to balance sulfate all in one package? You can do that. Sometimes you can do that. There you go. You can treat sulfate as 1. So if I were to do a color coding here, this we treat as 1. 1 sulfate, 1 sulfate. Okay, this is balance, yeah? Then what about your hydrogen? 2 hydrogen. Although you know it, but it's 2 hydrogen. It's 2 hydrogen. Okay, halas, it's balanced now. So you got 2 marks just to write this down. Okay. Now state the color of methyl orange in sulfuric acid. Now sulfuric acid is an acid, is a strong acid. Strong acid. Okay, methyl orange in acid. Okay, let's try to do a bit of a revision and at the same time try to memorize this, yeah? So we got 2 colors of methyl orange in alkali or in acid. It's very easy. in acid. Okay. In acid, now normally the color of, your pH, yeah, pH, let's say the easiest way to remember your pH paper. What is the pH paper for acid? Red, isn't it? That's how you try to remember. Okay, halas is red. Done. Okay. What about in alkali? It's actually yellow. So methyl orange, although the name is methyl orange, okay, in acid or alkali, there's no orange. Yeah, just remember that. It's either red or yellow. That two color only. It cannot be like green. It cannot be like, I don't know, purple or anything. Either red or yellow. Now, the best is actually, we always relate acid with red color. Always relate acid with red color. So this is one of the best way to remember. So in methyl orange in acid is actually red. So meaning in alkali, it should be yellow. That's one of the way for you to remember. Yeah, there you go. They ask you to state only. No need to do anything. No need to explain. There's nothing to explain. Alas, yeah, 1 mark. Now, the equation for the reaction between powdered zinc carbonate. Let's try to see the key point. You are using zinc carbonate, powdered zinc carbonate, and dilute nitric acid is shown. When we say dilute nitric acid, meaning this acid is actually diluted with what? With water. Yeah. So meaning what? Meaning water, meaning in aqueous. So that's how we can actually remember. Yeah. Try not to. If an acid, a dilute acid, is always in aqueous solution because it's actually diluted with water. Okay, what did they ask you? Complete the equation by adding the state symbol. All right, they already give you the equation and they already balance it. So what do they want you to do? They want you to just put down the symbol, the state symbol. Okay, they already told you here, powdered zinc carbonate. So the symbol for powdered zinc carbonate, it should be in the solid form. Yeah, in the solid form. So what you can do, normally we use a bracket here, yeah? So why not just put solid, there you go. Right. What about your nitric acid? Like we said just now, nitric acid should be in the aqueous, yeah? Aqueous, no doubt about that. Because dilute with water, aqueous, AQ. It's good just, although they didn't give you the bracket, just to put it in a bracket, there you go. All right. Now zinc nitrate, okay, any salt, yeah? Any salt is actually in the aqueous, yeah? Zinc nitrate is, this is a salt, aqueous. Okay, carbon dioxide, of course, is a gas. You see, 2 marks just for this, mashallah, yeah? It's a very easy question. Now, what about water? We cannot put water as aqueous. Okay, water is a liquid. Be very careful. So this is the only thing that maybe people will get a mistake, yeah? Sometimes a bit of confusion, a lot of people asking me, what about water? A lot of them putting water as aqueous. Why? Because when we have salt solution, when we got like dilute nitric acid, I told them, okay, it's a solution, and then you got water. Because of that, it's actually aqueous. And then they misunderstood. When we have like water itself, people always relate water to, okay, this must be aqueous. La. No. Yeah. For water, it's a liquid because water is when you got water molecule bonded to another water molecule by hydrogen bonding. Yeah, so it's a liquid. There is no way that you will have aqueous there. Only when we have like solution, water, we don't say water solution, isn't it? When something dissolve in water, only then we call it a solution. It's easy as that if you want to remember. Easier. Then don't get yourself confused. Now, next question. A student found that 2.5 gram of zinc carbonate. And they want you to do a calculation here. Zinc carbonate is a very good question indeed here for us to do practice. A student found that 2.5 gram of zinc carbonate required 20 cm cube of dilute nitric acid to react completely. Okay, I just want to do a bit of a theory here. We have what here? We have a metal carbonate. Let's do a theory, yeah? Carbonate. Then you add with what? Acid. Okay, acid. So you just do a generalize this metal carbonate with acid. What would you get? I think in the first class, I think we did mention about this. Of course, we will get salt. Of course, we will get water, salt and water. And then another thing is that we will get carbon dioxide, CO2. Yeah? So just do a symbol here. So this is the most important thing. So in other words, metal carbonate is a base. So we can actually treat metal carbonate as a base here. So if a base plus acid or an alkali plus acid, what do you get? Salt plus water. But because of the carbonate, you will get carbon dioxide. Only carbonate with acid here, you will get carbon dioxide. So using this theory, okay, we can actually try to create an equation. It's good to do an equation for this, yeah? So what can we do? We try to put the equation, although they didn't ask for that, but we do need it afterwards, yeah? So they already gave you the symbol for zinc carbonate. You see it? So just gather this zinc carbonate CO3. Oh, okay, the equation up there. Sorry. Don't need to rewrite this. There you go. Okay, from here we can use this equation, zinc carbonate and nitric acid. We got the salt, water, carbon dioxide. Okay, halas. But what do we need from here? We just can put the number of mole, yeah? No number in front of zinc carbonate, it must be 1. So only 1. So we can say only 1 mole of zinc carbonate reacts with, there is number 2 in front of nitric acid, 2 mole of nitric acid. How many salt zinc carbonate that we create? 1 mole. Water, 1 mole also. Carbon dioxide, 1 mole. Let's just run down the theory. Just a bit of a theory here. I think previously also I did mention about balanced chemical equation is a very important in chemistry. Why? Because it's just like a recipe. Just like when you're making a cake, it's not just sufficient enough just saying that somebody said, okay, this is my recipe for a cake. Uh, what you need is egg, flour, sugar, milk. Yeah. And then you ask that somebody to make a cake. So what is missing? The quantity. So it's not just sufficient to know the reactant and the product. Okay? The reactant is not sufficient enough. What we need is we do need the quantity of the reactant and how much product that I made. So this we can get from the balanced chemical equation. So that's why this is just a theory. This is why number of mole is very important. And I just want to introduce to you what does this number in front here means, yeah? And when there's no number, meaning it's 1 mole only. Okay, just all right. Now let's try to answer the question. Calculate the concentration of dilute nitric acid using the following steps. So this is a very easy question because they already did the step for you. So I don't need to do anything, yeah? So what is the first step? Calculate the mass of 1 mole of zinc carbonate. So the mass of 1 mole of zinc carbonate is what we call the MR. Yeah? So just use the formula. How many zinc? 1. And what is the mass of zinc? You don't need to memorize. Go back to the periodic table. Periodic table may be at the end. There's no need to memorize. There you go. There you go. Where is zinc? There you go. What is the mass of zinc? Which one? Okay, look. Periodic table, the bigger number is your mass. Very easy. Yeah. For example, you got 3 is the atomic number, 7 is the mass number. So what we want here is actually for zinc is actually 60, not 30. 30 is the atomic number. Remember that, yeah? So you got 65 here. Then we go back to the question. Go up, sorry. Rotate this. Okay, let's go back here. Bismillah. We're not going anywhere, so take it easy. Do not rush. What most important is actually your learning. Okay, halas then. So how to calculate 1 mole of zinc carbonate? All you need to do is that just to add all of this. 1 mole of zinc carbonate is the same as the MR. I'm sure everybody knows how to calculate the MR. So 65 plus, what is the mass of carbon? Like I said, you don't need to memorize this here. Plus, how many oxygen? 3 oxygen. What is for 1 oxygen? What's the mass? 16. No need to memorize everything in the periodic table. I have already shown to you how to get from the periodic table just now. Then we just key in this value in the, don't waste time. Key this in the calculator. 65 plus 12 plus. You can put in your calculator. Nowadays calculator is so good because you can even key in whatever that you wrote down here. Done. 125. There you go. Okay, done here. 5. Okay. Calculate the number of mole of zinc carbonate reacting. Okay, now you want to find the number of mole of zinc carbonate reacting. Okay, what is the formula that we can use? We can use the formula. Number of mole is small n. What's the formula? M over MR. Yeah. What's the mass of zinc carbonate reacting? Let's have a look. 2.5 gram. So 2.5 gram divided by MR 125. That's the number of mole here. Bismillah. So directly just type it in here. 2.5 divided by 125. This is a very important calculation in chemistry. 0.02. Go. 0.02. It's not that hard. Done with that. Determine the number of mole of nitric acid reacting. So this is why we do need the mole ratio. Okay, the number of mole. That's why we need the balanced chemical equation to find the mole ratio. Now for this case, what is the mole ratio that we're interested? We have only the info for zinc carbonate, number of mole of zinc carbonate. So what do you want? Nitric acid. So what you can do, look at the balanced chemical equation, then we can create a mole ratio. Okay, mole ratio that we want to create is between zinc carbonate and nitric acid. That's it. Yeah, I'm not concerned about the others, just this. Okay, look at the balanced chemical equation. Look, zinc carbonate 1 mole, nitric acid 2 mole. So the mole ratio is here 1 mole to 2. Okay. So what did we calculate? We calculated the mole of zinc carbonate. This one, this is what we got. But what do we want to find out? The nitric acid. So what we can do here is that rewrite this under the mole ratio. So meaning that from our calculation, although in the formula or the recipe, the 1 mole zinc carbonate reacts with 2 mole nitric acid, but actual, okay, the one that we use is actually only 0.02 mole. So if that is the case, from here we can compare. Yeah, we can use the mole ratio to compare. If 1:2, if we got 0.02, meaning this one you have to multiply by 2. 2 times 0.02. Okay, just calculate using your calculator. You have to show the calculation here. So that's why we're not doing mental arithmetic here. I know you can do, but the thing here is that is IGCSE, you have to show why you have to get full marks for this. Let's have a look at the marks. How many marks here? There's a lot of marks here. So you're going to put 0.04. Almost done. Now we want to find the concentration of your nitric acid. Okay, so you want to find the concentration. You got the number of mole, all right? And then now you want to find what is the concentration in mole per dm cube. Right, let's have a look here. What is actually the given for your nitric acid? Because this is a solution, yeah? The solution, they will not give you the, we will not use mass. What we should be using here is that they are using the volume here. So volume is 20 cm cube of nitric acid. So what happened here is that I have to use the volume. Yeah, volume of my nitric acid is 20 cm cube. So I cannot use what is the formula to find the concentration? Okay, concentration, I have to use the formula N equals to molarity, which is the concentration, multiplied by volume. This is a formula for you to remember. N equals to mv. What is m? M is the molarity or concentration. So from here, what's the volume? 20 cm cube. Look at the unit for the concentration, dm cube. So if that is the case, I have to change my volume from cm cube to dm cube. So 20 divided by 1000. It's easy as that, yeah? So I mean, in my calculation, okay, I would advise you to simplify your calculation, meaning that you simplify it here, okay? Directly, you just divide directly. Because why? Because we tend to do careless mistake if you don't do this. What will happen if you forgot to change this into the m cube? Your answer will be wrong. Right now, I want to find what? I want to find my m. So I just need to rearrange this formula. So m equals to NV. So NV bring to the other side divided by, that is M. So we can rewrite this M equals to number of mole divided by my volume, which is in the M cube. Then we can just directly substitute the value here. Yeah. What's the number of mole of nitric acid that I found from the mole ratio here? 0.04. So you just directly substitute 0.04. What's the volume in the M cube that I just got there? 0.02. You see, when you got everything here, it's easy for you to check afterward. Yeah. So that's why I told people I would insist you to simplify your calculation. No harm for you just to work out your volume in the M cube first, and only then you can actually put it here rather than putting everything here 20 over 1000. It would be, you know, you tend to do careless mistake. Now 0.04 divided by 0.02. There you go. So the answer is 2. Okay. And there, the answer is 2 here. All right. Okay, you can just use this number too. There's no need to put the decimal place. This is correct already. Halas. So we stop here, yeah.